Why, hello. Okay, here's the last question of the last part of your complex circuit. This is on the back, the very last one. And the idea for this worksheet, or the idea for this circuit, is to figure out current, voltage, and power going across each resistor. So the idea is going to be this. We have 6 volts, and this is complex. We have not only just parallel, but parallel in series with something else. Okay, so what you want to first do is figure out the total current running through this circuit. Okay, to figure out the total current running through the circuit, find the equivalent resistance. So we see a 2 and a 2 in parallel with a 1. You have to, like the other problems we've done, you want to start first with these two in parallel. So 2 and 2 in parallel, or 2 and 2 in series with 1, 2 and 2 in parallel becomes just 1 ohm. Okay, so you can imagine that this is really, get rid of those, and you really just have a 1 ohm resistor now in series with another 1 ohm resistor. 101 in series means the total resistance of this circuit is really just 2 ohms. Okay? Once you know that the total resistance, so basically it's like you have a simple circuit. You have a simple circuit of 2 ohms and 1 power supply giving 6 volts. Okay? And if that's the case, then you know that the current is going to be 6, V equals IR, and we know that, we know V and we know R, then V over R is going to be 6 divided by 2. Or 3 amps. Okay, so we know that there's really 3 amps that are going to run through this circuit. Okay, so that means 3 amps going through here, and it's going to get split up. All right. So if we have 3 amps running through the circuit, when it gets to this point here, it's going to get it split up. Because we know that they're the same resistor, all right, because it's a 2 and a 2, we know that there's going to be half going through each one. Because they're both the same resistance, we can say that 1.5 will run through here, and 1.5 will run through there. So going to the sheet here, we know that across one of the 2 ohm resistors will be 1.5 amps. Across the other one will also be 1.5 amps. When they meet back up over here, okay, and it starts to go through that 1 amp, or that 1 ohm resistor, they have to meet back up. The 2 small rivers meet up and add up. So the current running through the 1 ohm resistor will be 3. Okay, now, remember, V equals IR. So V equals IR, we know R, we know I. So to figure out the voltage going across one of the 2 ohm resistors would just be 2 times 1.5 or 3. All right, same with the other one. 1.5 amps going through a 2 ohm resistor. 2 times 1.5 is 3. So you're multiplying these two numbers. Okay. Going through this resistor here, we have 3 amps multiplied times 1 ohm resistor. So 3 times 1 is also 3. Okay. Now, if we want to look at the power, power again is P equals I times V. All right, P equals IV. Power is current times voltage, so 3 times 1.5 is 4.5. Same thing here, 4.5. And current times voltage for the bottom one, 3 times 3 will be 9. Okay? So, again, the voltages have to add up to the total. So let's see if it makes sense. We said that this is 3 volts. If this is 3 volts here, then the voltage across here has to be 3 volts also. 3 volts here, 3 volts here. Because they're in parallel, whatever voltage you have here is equal to the voltage you have there. But just one of them, 3 volts, okay? this point to that point, there's 3 volts. So 3 here plus 3 there should add up to your total voltage of 6. Okay, that's about it. Thank you very much.